We got here Michael DeBach. Carlos Aguilar. Not here yet. Travis Black. Jacob Childers. It's convenient when y'all sit in alphabetical order like that. Carter Dewberry. Carter Dewberry. Carlos Aguilar. Yeah. Jimmy Flood. No, I'm calling your name, but good morning. Derek Heineman. Pass this back to him, please. Jacob Hoffman. You. Kyle Kohler. Matt Letney. No Matt Letney. Jesse Martin. Deja McClellan. There she comes, just as I called her. Pour-vous. You're very welcome. Joey Najira. Sure, right here. Jory Owens. Lauren Pendergrass. That you? All right. Between you and Megan Walker, I'm going to have to put name tags on you. I keep getting y'all backwards. Val Peterson. Jimmy Reetkirk. No. Jared Robertson. Here, meet me halfway. In fact, this is convenient because there's Jesus Rodriguez. Brandon Simpson. Stephen Turner. Who just came in? Reetkirk, got one for you. Here. Thank you very much. Okay. Well, my folder got a lot thinner. Does anyone else want to turn in homework before class, or you want to keep it until you can keep working on it until after class? In case you want to change any answers between now and the end of class. Who has any questions about or from the homework? Oh, you just came in? Your name? Brandon? I got one for you. I'm on a mission to thin out my folder here. Oh, well, one page, not going to help much, but thanks. Seriously, no questions from the homework? Yeah, it was, wasn't it? What about from the last two, from the laws of sines and the laws of cosines? We're definitely gonna cover that. Name? Oh yeah. Front and center, got something for you. Jesse Martin. Yeah, it's somewhere. Everybody, including anyone else who came in after it started, make sure you get signed in on the attendance sheet. Anybody not sign the attendance roll? You haven't? Was it anybody that came in after I started handing out papers?
Yeah.
Hi, name? Tyler. Yeah. Kashua, yeah. I've already handed you back your stuff. Oh. All right. Just for one double check. Carter Dewberry, Kyle Kohler, Matt Letney, Joey Najira, Jory Owens. Oh yeah, I got you. And that's shoot. You pass that back, please. Thank you. Stephen Turner. All right, I guess I've got rid of all I'm going to get rid of. So, that ambiguous case, that we're definitely going to cover that one today. We want to go over that. That did seem to trip up a few of you. There's an exam on Tuesday. So, if you have any questions about the material from the last three sections, law of sines, law of cosines, or area of a triangle, Heron's law, now's the time to bring it up. Anybody need me to go through the proof of Heron's law again?
Yeah. I only got half of it.
Okay, well, as long as you remember the two things that you need to know. What are the two things you need to know? It's half the sum of the sides is defined as S. And that S is what becomes the four factors of the law. And if you'll recall, that fact that there were four factors gave his contemporaries a problem, which was, right, they thought of two factors was an area, three factors was a volume, what was four factors? But in fact, because you take the square root of four factors, the square root of 4 is 2, and you end up with a two-dimensional area. So don't forget that radical. Take the square root. I won't always be in a good mood when I'm grading papers and decide to give someone a break because they forgot to take the square root of something before they wrote down their answer. Now, what are the various cases where we can find out, where we know that we can solve a triangle? Okay, first case, you got a triangle. And you know all three of the angles. But you don't know the length of any side. What can you do? No, think this one through now. This is a trick question. You can create an infinite number of solutions. Name? Say again? Anthony, I don't think I have anything left for you. No. No, I'm pretty sure I've given back everything you had. Yep. I tried. If all you know are the angles, then you can create an infinite number of solutions. Pick a side, any side, and you can come up with the other two. But in order to solve a triangle, you must know at least one side. What else do you have to know? Of the 6 features that define a triangle, 3 sides, 3 angles, as long as you know one side, what else do you have to know? Any 2 of the other 5 features. Once you know 3 things, as long as one of them is a side, then you can solve for that triangle. So, let's talk about what are our choices for solving a triangle? Either law of sines or law of cosines. What's the law of sines? Anybody, call it out. Don't make me call names. Sine of A over A bingo. Where the sides are the opposite their angles. That's the key to using the law of sines. Make sure that you put, when you label the angles, make sure you align put the associated side opposite its own angle. Now, what's the law of cosines? There, this is the one that you got all the weird permutations. A squared equals B squared plus C squared
minus 2BC cosine A.
Bingo. And the other 2 permutations, B squared and C squared. And if you're solving for the B side B, then you're going to use the cosine of its associated angle. And again, when you draw your triangle to solve it, make sure you put the side opposite its associated angle. That's law of sines, law of cosines. Since we're writing down laws, all of which would probably look real nice on that standard index card you've got, we've got finally the law of Heron, which has 2 things you have to remember that you need to know in order to use it. First, you need the definition of S. 1/2 the sum of the sides. At which point you can then find the area K of the triangle as the square root of S times S minus A or plus A? Minus S minus A. What's your name?
Kyle Kohler.
Kyle Kohler. I definitely got something for you. Thank you. All right. S minus A, S minus B, S minus C. Get all of it under the radical. What's the other formula for K? There's one more. This one is handy if all you know are the three sides, but you don't know anything about the angles. One half base times height. Okay, but you can find height if you know an angle and a side adjacent to it. Megan Walker, do I have anything for you left? No, I don't think so either. But fortunately for you, Lauren was already here, so I could remember which one you were. C times the sine of A, or I'm sorry, C times the sine of B in that particular triangle gives you the height. So and actually, I'm going to have to change that base to A times A times C times the sine of B in that angle, in that triangle. You see why I'm using, which letters I'm using. In this case, A is the base, and if I know B and C, I got the height as C times the sine of B. Does everyone see that? Yeah? Okay. Go ahead. You don't, no, okay. All right. So, what if you don't remember how to arrange these sides and angles to use this formula? But you need to find the area of a triangle. Go ahead and solve for the third side. Use law of Heron. Me? Well, now let's talk about the different cases that you can encounter. We've already said that in order to solve a triangle, to solve a triangle means to find the 6 quantities that define a triangle. 3 angles and 3 sides. And if you know any 3 of those things, as long as one of them is a side, you can solve for that triangle using this information you have here. But which approach, which law will you use will depend on the case, on what you know about a triangle. So, let's talk about the first case where you know 2 angles and 1 side. That would be either angle, side, angle, or side, angle, angle. Which law do you use? Law of sines. What if you know 3 sides and no angles? You can use the law of cosines. What the book calls SSS, all 3 sides. If you know 2 angles in one side, law of cosines isn't going to help you. You can't solve 2 angles in one side with the law of cosines, because for every formula in the law of cosines, you have to know 2 of the sides. So let's talk about that case, where you know 2 sides and only 1 angle. Now you're either going to know side, side, angle, or side, angle, side. Does everyone understand this notation? When I say side, side, angle, that means you know 2 sides and the angle at either end, but not the angle between the 2 sides you know. Side, angle, side means you know 2 sides and the angle between them. So, which law do you use now? And this is the trick question. You'll use, depending on which of these 2 cases, if you know side, side, angle, then you need the law of sines. If you know the 2 sides with an angle between them, then you need the law of cosines. Now, let's take a look at this one in particular, where you know 2 sides and the angle subtended between them, and you are using the law of cosines to solve that triangle. This is the case where you're going to run into that ambiguous case. So let's get the book, let's turn to that page in the book so we can make sure we keep this straight. Uh-huh. And look at me, I've already gotten them backwards. This is not where you will run into the ambiguous case. This one is. It's in the law of sines. Now, here's how it happens. You know, 2 sides. How does the book label them again? No, it doesn't. It labels them. Now, in this case, you know B and C and angle A. And you don't know side B or angle C. And again, I told you wrong. Because angle A you do not. You do know. And side A, you know. It's B and C. It's angle B angle C and side C that you do not know? So, what you find out first is the height. Because you know angle A, you know that side C passes this way. First thing you need to find out is the height. You find height by as B times the sine of angle A. That gives you this distance, H. Does everybody remember this from the trigonometric functions? Okay. If A is less than H, that's the first possibility. If A is less than H, there is no solution to this triangle. This angle is defined, which means side C has to go in this direction. And if A is too short to reach it, you don't have a triangle. Does that make sense to everybody? Okay. If A is equal to H, exactly equal to H, then you have one and only one possible solution. And that is where angle B is a 90-degree right angle. Now, there's another case where A is greater than B. If A is greater than B, say again? Well, if it's, yeah, I think you're right. See, this is one that always perplexes me, because what they're saying in the book is if it's greater than B, then you can only form a triangle by bringing it out to here. But in fact, it seems to me like you could also bring it out here and form this triangle. But I got to stick with what the book says. Well, it would be a... That's right. A would be a different angle if that's... Thank you. That just clears that up. A would have to be a different angle, so it can't be. So if A is greater than or equal to B, then you have one and only one solution. Okay? The ambiguity comes into play. Let me wipe this off. The ambiguity comes into play when A is greater than H, but less than B. Because now it can come, you can bring it over to here to form this triangle, or you can bring it over to here to form that triangle. So you see, you get these two possible triangles. Everyone see this? With that angle A, that side A, both of these triangles are possible if A is greater than B but less than H. I'm sorry, If A is less than B, but greater than H. B is greater than A is greater than H. Thank you. Has this completely confused everybody? Let's walk through it one more time. Because it confuses me if I don't walk through it step by step. Say again?
I got it this time.
All right. It's this is the ambiguous case. You know, two sides and one angle you do not know angle C or angle B. Now, I really want you to understand how to think this through for yourself, because I don't want to, I think it would just make everything even more confusing if we tried to go through and do every possible permutation of, well, what if you know side C and angle and side B and angle C, but you don't know A or B. Get it straight in this case, and you should be able to apply this case to any case where you know two sides and an angle with the angle not between them. What are the possibilities? A is greater than H, A is equal to H, A is less than H. And if A is greater than H, then A is either greater than H and greater than B, or A is greater than H and A is less than B. Okay? If A is less than H, simple. No solutions. You cannot form a triangle. If A is not at least as tall as the triangle, you have no solutions. If A is exactly equal to H, you have one solution, a right triangle. The ambiguity comes when A is greater than H. If it's greater than H and it's also greater than B, you only have one solution. But if it's greater than H and it's less than B, then you have to solve for two possible solutions. Let's go through this example in the book here, example 5, because I think it'll benefit everybody to actually walk through and solve one of these. What do they give us? A equals 6, B equals 8, and A equals 35 degrees. All right. Lost somebody already, huh? By the way, what do we already know? We know that A is less than B. Because A is less than B, we have the possibility of two solutions. What do we need to know first? We need to know the height. What is the height? Eight times the sine of 35 degrees equals, somebody with a calculator. 4.59. Okay. Now we know that H is less than A and A is less than B. So right there we know we have two solutions. Well, let's solve for angle B. We know that sine of B over 8 is equal to the sine of 35 over 6. So sine B equals 8 over 6 times sine of 35, which is, somebody with a calculator? Say again? All right. Somebody else confirm that. Okay. Yeah. Well, it's right there in the book. I still like to go through and do the actual punch the buttons on the calculator. That's sort of the whole point of the exercise, is to learn the mechanics of actually working through one of these. That's why I want you to do the actual, use your calculators to do this along with me. So, all right. What are the possible solutions for sine equals 0.76? That's going to be somewhere close to 3/4 of the way up. So we've got that theta, that angle and that angle, both of which will provide a solution to this triangle. How do we find the first one? Just use your calculator and take the inverse sine. And that puts you at, what does that give you? 49.9? I did. But what's working against us right now? There are two angles. Why are we only getting one of them? The point I'm trying to make to you right now, the epiphany I'm trying to slow walk you to, is that this is one of those cases where you have to do the math. Let the calculator do the arithmetic, but you need to do the math. The inverse sine function has what is its range, domain, and range? It's only going to give you answers from minus pi over 2 to pi over 2, from 270 degrees or minus 90 degrees to plus 90 degrees. It will not give you that second possibility. You have to do that. Well, what then, how would you find theta 2? You know theta 1 is equal to 49.9 degrees. What is theta 2 equal to? Look at the picture of the unit circle. This is the angle we're looking for right here. What do we know about it? We know it's symmetrical about the y-axis. We also know that this angle is 180 degrees. So theta 2 is not 2 times 49.9. It's not 49.9 plus 90 degrees. It's 180 degrees minus 49.9 degrees. Because of symmetry, we know that this is also 49.9 degrees. And that's how you get this. 180 minus 49.9 gives you 130.1. So there are your two possible angles for B. And now you have to solve the triangle for both of those cases. So if A is 6, B is 8, A is 35 degrees, and B is 49.9 degrees, What do we still need? We need C and C. The angle C and the side C. Simplest way to do that is to say that the sine of C well, let me ask you. This is what we know. Somebody tell me, how do we solve for C and C? There you go. We can find C immediately, and that has the benefit of not relying on any, trigonometric algebra. It's just straight up addition. It's kind of hard to mess that one up, isn't it? You start taking, you start doing the squares of the sums of the squares of the sines of the, there's lots of room to make mistakes. 180 minus this minus that is anybody else get 95.1 degrees? Boom. Now, we find C simply by using sine of 95.1 over C is equal to, pick one of the other sets, sine of 35 over 6. Solve for C. Multiply both sides by C. And yes, I'm going to walk through this step by step. It's good for you to work your way through the algebra step by step, just like you work your way through everything. These cancel. Multiply both sides by 6. And divide both sides by sine 35. And you end up with 6 times sine 95.1 over sine of 35 equals C equals who's got an answer? You got 10.42? Anybody else get that? That's your first solution. What is your second solution? A equals 6, B equals 8, A equals 35, B equals 130.1. Thank you. Seriously. So now, what is C and C? Say again?
14.9.
14.9 degrees. And sine of 14.9 degrees divided by C equals sine of 35 divided by 6. Multiply both sides by c. Divide both sides by sine 35. And multiply both sides by 6. And you end up with 6 times sine 14.9 divided by sine 35 equals C. Somebody else get that? Anybody? And there is your second solution. But it is imperative that you keep it straight. Don't get the idea that you've got it and you can just, rush through it and do it off the top of your head. Write it down step by step. Draw the angle, draw the triangle. Make sure you know which side and which angle you're talking about. And work through it stepwise. It is one of those cases, it is one of those times where your calculator will not give you the answer. Your calculator will do the arithmetic, but it will not do the math. You have to do the math. Any questions about it? Everybody here can handle the ambiguous case? Can everybody here tell when you have the ambiguous case? Now that I've erased, no I haven't. All right, do some drills. Say again?
On the test, the triangle you have drawn, is that how you're going to want it to orient or angle the side? Over there you had the A, B, C,
Yeah, I know. I try to do them the way the book has them labeled when I work through the problems. So no, the way the book does it normally, I think, somebody correct me if I'm wrong here. I think the book starts by labeling this A. Is that A or B? Yeah, and then they go counterclockwise, B to C. The important thing, well, again, that depends on whether they're talking about the angle of the formula for the area of a triangle or are using the laws of sines and cosines. One of the things I don't like about this book is that when they start talking about the area of a triangle, then they put B on the bottom because they're calling it the base. And you're doing base times height. But when you look at the laws of sines and cosines, at least when I have, this is how they label the sides. A, B, and then C at the bottom. And they do it right to left, counterclockwise. So it's completely backwards. But this is the important thing. This is what you need to remember when you are drawing your triangle, if there's no triangle drawn and you're drawing your triangle, the only thing that matters is that your angles are opposite their associated sides. Okay? That's what matters. That's how they will line up correctly with the law of sines and cosines, the way you've memorized them. Now, you know all three sides, nothing else. What law do you use? Say again? Law of cosines. What other case would you always use the law of cosines? Thank you. Side, angle, side. In either of these cases, you're never going to have an ambiguous case. Side, side, angle. Law of sines. You know two angles and the side between them. Law of sines. What if you know two angles and one of the sides that is not between them? Law of sines. No, you're going to have something like this on your card. But what if you didn't? What if you got lazy or procrastinated? Because even though it's a well-known fact, it's documented that students are biologically incapable of procrastination. But just suppose something happened. You caught a virus and you procrastinated and didn't write this stuff down. Could you figure out which one to use? And just to keep it interesting for him, let's jumble up the way we label the... No, I'm going to make that A, B, and C. What angle is this? B. What angle is that? C. What angle is that? A. You know that. How would you figure out what to do, what to use? Could you use the law of sines? Well, in order to use the law of sines, you have to know at least one angle and its opposite side. Huh? You're solving this triangle. You know three things. You know A, B, and C, angle C. But forget about which side is A and which side is B. You know this side and this side and this angle. Look at it this way. Just look at the picture of what you got. Can you use sine? You only know one angle, and that's sine of C. Divided by what? Divided by your unknown. Well, that's got to be set equal to another angle and another side. you don't have enough information to use the law of sines here. So that, if you don't have all of this written down on your card, that is an excellent way to start addressing the problem. Instead of panicking and saying, oh no, I don't know which formula to use, look at the information you have. What formulas do you have? Do you have enough information to use that formula? You do have enough information to use the law of cosines. Because now you can say, you know A and B in an angle, so you can say A squared plus B squared minus 2AB cosine of 30 is equal to something, C squared. And you know all of these numbers, you can just punch them into your calculator as long as you're careful. And remember to take this, listen up, everybody. And the two or three of you who I'm talking to, you know who you are. Do not forget to push the square root button. I will not always be in a good mood. For any given problem, and this is true not only in this class, but in all of your classes, physics, biology, chemistry, you're going to be given a set of information. Write down what you know. Draw a picture of it. And then think about what you can solve based on what you know. Don't just suddenly realize, oh, I forgot to write that down, and panic. Which one of these is going to give you an ambiguous case? This one here. And draw the picture. If you don't remember all that, if this is greater than that, if that is less than, draw the picture. Once you draw that picture, things will start to get real clear. Will this side reach the bottom? If it won't, do you care about that? You can write that just because you know A is less than H, it won't reach. No solution. Probably the best advice anyone can give you for taking tests in any class. Just don't panic. Just breathe. And if you find yourself stressing and unable to think, close your eyes, stop looking at the problem, and take a breath. Then think about, what do I know? Any more questions before I turn y'all loose? Yeah, I know, I got another 20 minutes, but is there anything any of you think you need more we need to cover that's going to be in one of these three sections? Have a good weekend. I will see y'all on Tuesday with an exam for you.